Today on Capechi's Corner, we're going to look at inverse matrices. Now, in things that you've known from the past, if you multiply something like 5 times 1 over 5 is equal to 1, that works because 5 and 1 over 5 are multiplicative inverses. We have a similar identity matrix in which we can do that with. So in a 2 by 2 matrix, we're looking for, if I multiply these two together, instead of getting 1, we're getting this identity matrix, which looks like that. The same thing, if I have two inverses and I multiply them together and they're 3 by 3, they're going to look like that matrix. Now, we're going to practice two things today. First of all, we're going to try to figure out, if I give you two matrices, can you figure out if they are inverses? And the other thing is, if I just give you one matrix, can you find the inverse of that particular matrix? So let's start with the first. Okay, so I want to know if F and G right here are inverses of one another. So to save some time, I started things a little bit. So in this first one, I have F times G. And I've done some setup already just to save some time. And we've done this in previous lessons. I'm multiplying this row by that column, which is right here. And I've done the same thing and I've combined them. Again, the fractions make it a little tricky. But once I've done that for all of it and I combine what I have, 9/4 minus 5 over 4 gives us 4 over 4, which is 1. On the bottom here, that gives us 0. Up top, that also gives us 0, and this gives us a 1. That's if I multiply F times G. Now, I'm going to do the opposite here. And I multiply G times F. Now, remember, I've said in previous lessons, I like to rewrite them because I have a hard time looking at things backwards. I think it's a little difficult. So I multiplied again, multiplied and got my column. So I have this one, this row by that column, and I got this right here, simplified here. Now again, what am I going to get at the bottom? 9/4 minus 10 over 8 gives me 1. 3/4 minus 6 over 8 gives me 0. Negative 15 over 4 plus 30 over 8 gives me 0 as well. And then my last one, negative 5 over 4 plus 18 over 8 gives me 1. So you can see that F and G are inverses because when I multiply them together, regardless of which way I do it, I do get that inverse matrix. Now, in our second part of our lesson, we want to find out if we have an inverse. What is the inverse? So some matrices do not have inverses. You can determine whether a matrix has an inverse by using the determinant, which we've used before. So let's take a look. This is kind of our little setup, and I have an example that we're going to work on it together. So the first thing I need to do is I need to find out what the determinant is, and I'm going to do that up here. So I took A times D minus B times C, and I'm going to put that in the denominator there. So the determinant's going to go on the bottom. And then I'm going to multiply that by this pattern here, which we'll talk about in just a minute. And that'll give us the inverse matrix. So I have number 1 set up. So I multiplied 7 times 1, negative 1 gives me negative 7, minus 2 times negative 5. So that's negative 7 plus 10. So our determinant is 3. Now my determinant is going to be my denominator. So I'm going to multiply this matrix that I have times 1/3. Now, what matrix do I use to multiply? Well, it's not going to be the original one. So we do have a pattern which I've color-coded, which will hopefully help you. If you look at the purple, I'm going to take 7 and negative 1. I'm just going to switch their locations, switch their spots. And if you look at the blue values here, all I did was I kept them in the same locations, but I did the opposite. So 2 became negative 2, and negative 5 became positive 5. Now, I will multiply through that number up front, the 1/3. So I get negative 1/3, and then I have negative 2/3, and then I have 5 over 3, and I have 7 over 3. So this is the inverse matrix of matrix P, which we call P prime. If I were to multiply this matrix by our original matrix, we would get that pattern that we talked about earlier with the 1s and the 0s. Okay, let's look at our last problem for today. I have our original matrix is Q, so let's try to find our determinant first. So I have negative times 9 gives me negative 72, and I have 12 times negative 6 is negative 72 as well. We have that minus in between. So I have negative 72 plus 72, so our determinant is 0. Let's go back to our setup here. So I have 1 divided by 0. Now again, it doesn't matter what numbers I have in my matrix. I can't divide by 0, right? So this is not going to work. So what that means is that the inverse Q prime does not exist because the determinant is 0. Determinant is 0, and we know that we cannot divide by a 0. Okay, great job today. Have a good one.